Okay, hi. This is part A topics review probability. Yeah. So before we move on to this handout has 17 questions. I will quickly just discuss three important points of probability. So here's the first one. Yeah. Probability of any event is always between 0 and 1, including 0, including 1. In other words, it's going to be 0% up to 100%, including both 0 and 100%. That's the first important point. Second important point is that the probability of an event is equal to favorable outcomes upon total outcomes. And the third important point is that the probability of an event to occur plus the probability of that event not occurring together is 1 or equals to 100%. So based on these three important factors, important points, we'll review probability, three major themes. If you're from India, then the three major themes are working with coins, fair coins called unbiased coins, where the probability of getting ahead is equal to that of a tail. Okay. And then the second one is dice. You roll two dice. Yeah. So again, a fair dice always has a sum of seven on the opposite faces. And the third one is a pack of playing cards. This is 52 cards with 13 cards being in each suit. 26 black cards, 26 red cards, red being hearts and diamonds, black being clubs and spades. So three major themes are used. Okay. So let's begin with the questions. First question is a team consists of four men and five women. If five members are to be chosen at random for a tournament, what is the probability of selecting two men and three women? So out here we use the second point, which is probability of an event is favorable outcome upon total outcome. Yeah. So first we always write down the total outcome out here. Why do we write down the total outcome? Because we know that the favorable is a subset of the total. That way, if you are writing the numerator, which is the favorable outcome, which is not part of the denominator, which is the total outcome, then you know that you're going wrong somewhere. Um, to explain you this point, let me just take a simple example where I can actually show you the sample space, which is the total outcome. Okay. Let me see if the question is there in coins. Yeah. So it is there in the points, but I'll just discuss it right now since we are discussing this question. So consider um, two coins. Okay. Hang on. So in the two coins, if you're tossing two coins, fair coins, okay. Now remember, fair coin means probability of head is equal to that of a tail. So if you're tossing two coins, or if you're tossing one coin twice, both will give you the same sample space or the total outcome, you could say. So the total outcome out here is for the two coins, coin one, coin two. This is how it goes: head, head, yeah, head, tail, head, and tail, tail. So that's my sample space. So I've got four outputs. Okay, right? Now, if I were to, have a question that is, if I toss two coins, what is the probability of getting one head. Yeah, what is the probability of getting one head? So if you write down the total outcome first, that is HH, HT, TH, and TT, like that. So you know your total outcome is 4. And you know that within this total outcome, your answer should be for one head. Yeah. So that is HT and TH. Yeah. HT and TH. So that is two outcomes. So you know that if you write down the total outcomes first, then the favorable is a subset of one of these four. So that's the point I'm trying to make for this question. For point number two, which is favorable outcomes upon total outcomes. Okay. So if you were to go wrong, for example, if you were not to write the total outcome first, and the question was if you're tossing 2 coins, what's the probability of getting ahead? Then you might just say head and tail. So my two outcomes are here, and I'm getting ahead. So you'd say the answer is one out of two, which is kind of surprisingly the actual answer half, but this is incorrect way of solving the question because your actual total outcome is not two but four. Okay, so again, um, you know, this is just a coincidence half, which is matching with the actual answer, but it's a wrong way of looking at the question. Okay, it doesn't work that way. So to give you another example out here, that suppose you thought getting ahead. Okay, so you might just say, okay, my total outcome is head tail. Yeah, or perhaps you know you took head tail, and then you took head and tail, something like that you took. Okay, and you said, okay, my getting one head. So you took one head as this H out here. So in a way, you would have got 1/4 as the answer, which is kind of incorrect because your sample space, your total outcome is incorrect. So maybe you can use this as an example, all right, as to how you could go wrong if you got the total outcome itself wrong. That is, you've taken head, then tail, then head, and tail, which is an incorrect total outcome. So that's what I meant. That make sure you write down the total outcomes first. Okay, so that is favorable upon the total here. And out here, total is the number of ways you can select five members, regardless of whether they are two men, three women, whether they are all five men, whether they're all five women, whether they're three men, two women, and so on and so forth. So you just randomly selecting five people out of the nine people which are here. So the total outcome will be 9C5. That's your total outcome. Just selecting five people randomly from the nine people. And those five people would be like five men, or it could be five women, or it could be two men and three women, or it could be three men, two women, one man, four women, things like that. Okay. So 9C5 is the total outcome. The favorable outcome is the question, the probability of selecting two men and three women. So and means into, all right, or means plus. Remember that or means plus. So out here it's not or, it's and. Correct. So selecting two men and three women. So two men I can select 4C two ways, and three women I can select 5C three ways. So that's my answer. Okay. So I won't be simplifying each and every one, but for this is the first one. So I'll just simplify it for you. So it's 4 into 3 upon 1 into 2. That's the shortcut. Or you can use the NCR formula, which is n factorial or n minus r factorial into r factorial. So you can go through my video on counting and combinatorics to understand this part. Okay. So right now I'm just moving on. So that's the numerator part. Multiply with 5C3. So I can go 5C3 like 5 4 3, and then 1 2 3 like that. Okay, and then 9C5 I can go 9 8 7 6 5 upon 1 2 3 4 5. Got it? So just understand this is how it goes with selection questions. Yeah, the P is not used, the C is used. So this is 12 over 2 6. This is 20 over 2 10. This is 18 times 7. Yeah. So 6 goes into 18 three times. And that's it. My answer is 10 over 21. So that's the probability of selecting two men and three women. Yeah. If I were to, select five people such that it is two men and three women out of four men and five women. Got it? So that's my answer. 10 over 21, or simply this one, 4C2 into 5C3 upon 9C5. I was discussing about OR part. So let me see if there's an example I can discuss with you from within these questions about the OR part. Yeah. So I was clever to put in OR part so that you understand that the difference between and OR in the total outcome and the favorable outcome part. So let's go through this question. A team consists of four men and five women. If four members are to be chosen at random for a tournament, what is the probability of selecting four men or four women? So out here, your total outcome will be what? It will be four members out of nine. So it will be 9C4. Okay, 9C4. Yeah. And probability of selecting four men. So four men is 4C4 because there are four men and you're selecting four men, or meaning plus or 5C4. Understood? Yeah. So remember this part. Okay. Now the distinction out here is that in the previous example, it was four men or I think two men and three women, if I'm not wrong. Okay. I can just move up and check the question. Yeah, two men and three women. Okay. So remember out here it was 9C5 and I had to select five people, five members. So I had done 4C2 into 5C3. Now see the distinction out here. The important part which I want to draw your attention to is that when it is an AND thing, these two numbers out here should add up to give you a total of this number out here. Very important. Whereas in the OR case, individually these numbers should match individually like that. So do not write 8 out here using the AND ka concept. It's not 8, it's going to remain 4 out here. Out here, if it's 2 and 3, they should add up to give you 5 down here. So just remember, write down the bottom part first so you'll realize that what is this 2 and 3 thing. Um, well, it's a very crude way of explaining it to you, but these are just certain pointers that you can relate to when you're solving these kind of questions. I'm moving on to the third question. A jar contains 4 red, 5 blue, 6 green marbles. If 6 marbles are taken out at random, what's the probability of selecting 2 red and 4 green? So very easy. The total outcome is to select 6 marbles anyhow from these out here. So that is 4, 5, and 6, which is 15. So 15C6. Yeah. What's the probability of selecting 2 red? Yeah. So 2 red and 4 green. Okay. So in certain textbooks, yeah, they don't write 15C6. Instead of 15C6, they write 15C6 like that, and with a curly bracket like this. I'm sorry, C bracket like this. Yeah. So this is just the same thing as 15C6. Okay. So 2 red, it'll be 4C2. Yeah. And 4 green. So into, and means into 6C4. Got it? And out here, it would have been written as 4-2 and 6-4. It's just the way they use they denote it by C brackets. Okay, so that's your answer. Simplify it and you'll get your answer. Yeah, the fraction. Remember, if the answer goes beyond 100%, that is beyond 1 or lesser than 0, that means there's some mistake in your calculation or in your solving the question. Okay. Fourth question. Right. A jar contains four red, five blue, six green marbles. If three marbles are taken out at random, what is the probability of selecting three red or three blue or three green? So that or part I'm bringing in so that you get enough practice on this thing. So three marbles are taken at randoms out of how many? Out of four red, five blue, and six green. So that's again 15 total marbles, and you're selecting any three out of them. Yeah. So that's your total outcome, 15 C3, and your favorable is the question itself, probability of selecting three red, so three red, or three blue, so that is 5C3, or three green, 6C3. So basically, this is nothing but you're adding up the individual probabilities. In a nutshell, this is what's happening. Understood? Got it? Another way to look at it. Okay? Same thing. Moving on. Question 5. A fair coin is tossed twice. Yeah. So again, I like to repeat. Fair means unbiased. Unbiased meaning the probability of head is equal to that of a tail. A biased coin would be a rigged coin, meaning the probability of head would not be equal to that of a tail. Okay. Yeah. So a fair coin is, the it's perfectly symmetric, weighing equally on both faces. Yeah. Things like that. Okay. So again, one more thing. If you're tossing a coin twice, or if you're tossing two coins together, meaning you दो coin लिया, toss किया साथ में, एक साथ में, or you're taking one coin, yeah, and you're tossing it once and then the second time, the outcome is going to remain head head, tail head, head tail, tail tail. Okay, these are your total outcomes. Okay. Find the probability of A, exactly one head. So that is TH, HT upon 4. So basically it's 2 out of 4, right? Exactly one head would be this and this. Exactly one. B, at least one head. At least meaning one or more than one. So that will be TH, HT, and HH. So that is 3 upon 4. Got it? Yeah. And at most one head. At most one head meaning one head or no heads at all. So that'll be TH, HT, and no heads would be tail tail. No heads. So that's again upon 4. So that's 3 out of 4. So remember these words. All right. This is kind of, you know, controversial. So, but yet I just put it in so that you understand that words do matter. Yeah. Okay. So these are common. Again. Three fair coins are tossed, find probably getting no heads. So when you're tossing three coins, coin one, coin two, coin three, these are the 8 outcomes you'll get. Yeah. So in case if you have forgotten a combination, yeah. So just remember that whenever you're discussing coins, right? So coins have two faces. Okay. So if it's one coin tossed, then it is 2 to the power 1. These are the total outcomes. If it's two coins tossed, then the power should be 2 for 2 coins. So these are the 4 outcomes you'll get: HT, TH, HH, and TT. And if there are 3 coins tossed, and remember the power will be 3 for the 3 coins, and the total outcomes will be 8. So you know that you'll have to count 8 total. So these are only 4. Yeah. So then I'll go with TT and H, fifth one, HH and T, sixth one, and I can have HH later on also. So HH and then T and TT and then H. So these are my, 4 and 4 outcomes, 8 outcomes. Okay. So 3 fair coins are tossed. Find the probability of getting no heads. So clearly no heads is this one. So it was a very simple question, 1 out of 8. Make sense? Yeah, no heads. So, yeah. Now, an important question that follows. I hope I have put that in the sequence. A fair coin is tossed 6 times. No, I have not. So let me just discuss this part with you. Okay. The sixth question. Three fair coins are tossed. Find the probability of getting no heads. So if I were to use, instead of no heads, find the probability of getting at least one head. Okay. At least one head. Right. So if you remember those 8 outcomes, there was only one which had no heads. Rest all of them had at least one head to it, meaning it was head, head, head also. It was two heads and one tail, and it was one head and two tails. So let me write it down again for you, for those people who want to understand this properly. Yeah. So this is THH, THT. Yeah. Um, then it will be HH and T, and it'll be TT and H. Okay. Yeah. So out here, if you see, all of these have at least one head to it, as you can see. Got it? So if the question is three fair coins are tossed, find the probability of getting at least one head. So no need to just write down all of these things. Just simply find out the probability of getting no heads, that is 1 out of 8, and subtract it from 1. So out here we call upon the third point, which I discussed at the beginning, that is probability of an event to occur plus the probability of that event not occurring is equal to 1. So out here the probability of the event is what? At least one head. So that we leave it as it is. So at least one head, opposite of that is no head at all. So no head is 1 by 8. And therefore my answer for this event about at least one head is 1 minus 1 by 8. So that's how I get this answer out here. Got it, guys? How I got this answer? That is 7 by 8. Understood? Find the probability of getting at least one head. So I'm not wasting my time finding out the different combinations. Yeah. I'm simply finding out the combination that gives me no head and subtracting it from one, because then I know I'll get all the remaining combinations. Yeah. Okay. Right. Let me just check the time. So I usually want to keep my videos around 30 minutes, not more than that. Usually it is 18 to 20 minutes, so it's easier to upload, and I wind up saving a lot of time because it just uploads faster. So right now I don't know where to check the time, how much time I'm into this. Um, I can't figure out. I don't know what time I started. So anyway, I'll do two more questions, or maybe just this question, and I'll wind up for the day. Okay. So the seventh question: a fair coin is tossed 6 times. Find the probability of the following: exactly three heads and at least one head. Okay. So remember, I told you that 2 to the power 6 for 6 coins tossed. So that'll be my total outcome. Yeah. That is 64 in this case. Yeah. Total outcome is 64. Okay, find the probability of getting exactly three heads. Okay, so I'm not going to waste time writing down H, 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 T, 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 yeah, H, 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 and these are the ways I would get my 64 combinations. And out of these 64 combinations, I have to pick up all those combinations that give me three heads exactly. Right. So remember, you're tossing 6 coins, so you can't just have three H's on its own. It has to go along with three other things. All right, which could be H, T, and T, anything. So there are three H's and it could be three tails. Yeah, there are three H's and it could be obviously three tails only. There's no other option. Or you can have five H's and one T. So these are all the other 64 combinations which are there, but my focus is on the question which is exactly three heads I want. Therefore, I'm gonna figure out how many combinations of three H's and three T's are there within the 64. So therefore, you need to recall arrangement of letters. So you got to look at my previous video for arrangement of letters. What does that mean? So those who already know this concept of arrangement of letters, then please go ahead. Those who do not know, then go through my video. So previous videos on counting and combinatorics. So I'll have to figure out how many ways the three H's and three T's can be, you know, uh, arranged. Yeah. Obviously, where the order does not matter. Yeah, where the order does not matter. So, right, right. Actually, order does matter. So, obviously, the order does matter because if I take HT, 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 then the order does matter, right? There are three H's out here and three T's out here. So where the order does matter. So I'm going to figure out how many ways to get this. So simply use the arrangement of letters concept. That is 6 factorial because there are 6 letters divided by the repetitions. That is 3 H's are coming and 3 T's are coming, 3 factorial and 3 factorial. So that will be my favorable outcome of exactly 3 heads. So this answer, whatever this answer comes to, divided by 64, that is 2 raised to 6. That's the probability of getting exactly 3 heads when I'm tossing 6 coins, pair coins. Okay, understood? Yeah. So yeah, the order does matter because otherwise it would just come up to 1 by 64 if the order was not important. Not 1 by 64, yeah, 1 by 64 actually. But the 64 wouldn't be there also because then if you're not considering order not important, then you would not have 64 different outcomes also. So an important point, but I don't want you to really think about this because it requires a little bit of critical analysis or a little bit of deep thinking, which I don't want you to do right now. I just want you to understand this topic superficially, if possible, if this you call superficially, because it's kind of complicated, probability. Okay. Yeah. So, yeah, that's the answer for exactly 3 heads. Let's move on to the second part, which is at least one head. So, at least one head. So I had already discussed with a smaller example of 3 points being tossed. Yeah. So remember, out of the 64, there's only one outcome out of the 64, which is all tails. Rest all will have at least one head in it. Like it'll be 3 H's and three tails. It'll be 4 H's and 2 tails, and there'll be combinations, different arrangements of 5 H's and 1 T, different arrangements of 4 H's and 2 T's, 3 H's and 3 T's, 5 T's and 1 H, things like that. Yeah. 5 T's and 1 H, and you could have all tails. So all tails arrangement is only one because there's only out of 64, there's only one of all H's and one of all T's. Question out here is at least one head. So remember, there's only one out of the 64 which has no heads. One out of 64 which has no heads. Simply subtract this from one, and you'll end up getting the answer for at least one head, 63 by 60. Right. Okay. Moving on to, I think I'll stop here. All right. And I'll continue with question number 8 from in my next video. So I hope to complete this probability concept in the next video. If not, then it might go up to 3 videos. Yeah. Thank you.